Hello, pre-calculus students. This is Mr. McAllen, and it's Unit 7, Day 15. We're going to solve linear trig equations today. We had a little introductory video yesterday. We're going to do some more with it, and we are going to talk about how we deal with radians today. So I'm just going to highlight radians just to make sure that I keep note of that. So the first thing we want to do when we have a linear trig equation is we want to solve for the trig ratio that we're eventually going to solve for the angle for. So in this case, in our first example, we have 4 cosine of x plus 1 equals 2 cosine of x. So we want to solve for cosine. And so when we do that, we're going to subtract 2 cosine of x to the other side. And we're going to subtract 1 to get that to the right side. So we're basically solving this like a linear equation. So I've got 2 cosine of x on the left, and that equals -1 on the right. Now I'm going to solve for cosine and divide by 2. So cosine of x is equal to -1/2. And this brings us back to what we saw in class today. In class today, we started out with a ratio. We saw what the sides were. Since we're not using a calculator, we know that there are only so many angles that this could be. And we basically identify from looking at the coordinate system and understanding that ASTC is a way to remember when cosine, sine, tangent, or any other trig ratio. It helps us organize where we are as far as a positive or negative ratio. Cosines are only positive in A or C. So because it's a negative ratio, we know our angles are in the S quadrant and T quadrant. So that being said, I'm going to draw in another color a triangle that is in quadrant 3 and another triangle that is in quadrant 2 and quadrant 3. I'm going to put the sides. This is -1 for the adjacent side. So that works for both triangle top and bottom. The 2 goes on the hypotenuse, and root 3 is negative on this side, and root 3 is positive on this side. So from this layout, we know that our reference angle has got to equal 60 degrees. Now this is if you're working in degrees. So it's got to be 60 degrees, and because of that, we can now figure out what these angles are. An angle with 60 degrees in quadrant 2 is 120 degrees because the 60 is what you need to get to the horizontal. And an angle in quadrant, so x1, our first solution, would be 120 degrees. And x2, my second solution, is in quadrant 3. And that, because of that reference angle being 60, its value is going to be 240 degrees. So my second angle is 240 degrees, and that would be the end of my solution for this problem. Now, we're going to do the same exact problem, but we're going to work in radians. So this is going back to doing some work that we did before with radians. First of all, when we solve this equation, it's going to be the exact same thing. Our reference angle, instead of calling it 60, we're going to call our reference angle pi over 3. Now, when it's pi over 3, you know that your solution from what you just did is going to be in quadrant 2 and quadrant 3. So when you draw that angle out, you know that your angle has got to be in this quadrant or in this quadrant. And the reference angle, I'll just work on the first one. It's got to be pi over 3. So this is how you figure out your radian amount. You know that this is 0 radians, this is pi over 2 radians, this is pi radians. So in order to get this angle, you need to subtract from pi over 3. So how do you do that? Well, you change pi to being over 3, so it's 3 pi over 3. You subtract pi over 3, so your first solution, the one in quadrant 2, is equal to 2 pi over 3. And that came from doing the subtraction of pi radians minus pi over 3 to go backwards, pi over 3 radians. So now my second solution is in quadrant 3. So this angle here is pi over 3. And if I use this as as a marker for, the horizontal, if I know that that's 3 pi over 3 there, then my next angle, x2, is going to be when I add pi over 3 to that. So my final answer is going to be 4 pi over 3. So here are some things to remember. Your reference angles in degrees. So here's a reference angle in degrees, and here's in radians. So in degrees, you have 0, well, you have 30, 45, or 60. The reference angle in radians would be pi over 6, pi over 4, pi over 3. These are all your radian reference angles. You have two other angles to keep track of. If you have a 0 degree reference angle, which isn't really a reference angle, but it's a 0 degree quantity, you know that it's an integer multiple of pi. So you would either say pi over 1, 2 pi over 1, 3 pi over 1. Anytime you're at a whole number pi over 1, which we would never say over 1 over 1 over 1, we would just say, pi, 2 pi, 3 pi. That's equivalent to having a 0 degree reference angle, or your terminal side is on the x-axis. If you had a 90 degree, angle, that angle would always be related to an odd multiple of pi over 2. So it would be pi over 2, it'd be 3 pi over 2, 5 pi over 2. Anytime you have a radian over 2 that's simplified, the reference angle for that would be pi over 2. So saying that, and we worked on that in class also, let's go and solve the next problem. Here we have cosecant. We want to solve for this ratio. So what we're going to do is we have root 2 cosecant of x is equal to -2. Now we're going to divide by root 2. So cosecant of x is equal to -2 over root 2. Don't rationalize. We want to turn this into its regular trig ratio. So that'll be sine of x is equal to root 2 over 2 with the negative out in front. Hopefully from this ratio, you notice that the reference angle is 45 degrees. Another thing to point out, how do I know to use degrees or radians? It's all in this domain statement. This domain statement says what the angle should be in. Should it be in degrees or radians, and from what values am I looking? So this is saying one full rotation, clockwise, one full positive rotation, counterclockwise rotation, and that's where I should find those angles. So now that I know my reference angle is 45, I'm going to draw up my coordinate system, and I'm going to look for where it's going to be, where sine is negative. That would be in quadrant 3 and quadrant 4. So I'm going to draw my trig triangles in those quadrants. This is 45 reference. This is 45 reference. And, this side would be -1. This would be -1. This would be root 2. This side would be -1. This would be +1. This would be root 2. The big thing is what is x1? X1 is going to be 180 plus 45. So that'd be a 225 degree angle. And the other angle would be all the way around to 315 degrees. So hopefully this has helped you understand how to solve some of these simple trig equations. And now let's do the same thing again, but in radians. So the same exact problem we just had, we finally get to cosecant of x is equal to 2 over root 2 negative. That means sine of x is equal to root 2 over 2, which is negative. Now your reference angle, because it's a 45, 45, 90, now your reference angle is pi over 4. So now you need to use that information to figure out what these angles would be called in radians. So this angle down here is pi over 4. And this angle over here is pi over 4. So this is 2 pi. I'm going to backtrack by pi over 4. So remember, 2 pi changed to pi over 4 radians is going to be 8 pi over 4. I'm going to minus pi over 4 from that. So my second angle is going to be 8 pi over 4 minus pi over 4, which you could have already done the math. I'm just going really slow here. So that's 7 pi over 4. And then x1, the first solution, is, because this is 4 pi over 4 at the 180 mark, I'm going to add pi over 4, so my other solution is 5 pi over 4. Hopefully this video has helped you understand how to do things in both degrees and radians for linear trig equations. We'll be doing more problems in class, but this is your primary instruction for tomorrow to get going on our next workout with trig. Have a good day, and I look forward to hearing your comments.